Well, the question says, excuse me, a circle having C as a center and a radius of 10 units is drawn. PTR is a tangent to this circle at T, R, C, and T are the vertices of the triangle of a triangle. TR is equal to 20 units. Well, now question 4.1 says, give a reason why TC is perpendicular to TR. So I'm gonna write the question here, 4.1. Okay, we need to give the reason why TC is perpendicular to TR. Well, when you look at the line TC is the radius, okay? It's the radius of over the circle, okay? And then TR is tangent to the circle. Now, we do know this property that the radius is perpendicular. The reason is that the radius, okay, the radius is perpendicular to the tangent line, okay? The tangent line. So that's the reason. Okay, TC is the radius, that's TC. Therefore, TC is perpendicular to TR. TC is the radius, and then TR is the tangent line. Now, question 4.2. Okay, that was 4.1, and now we're going to do 4.2. The question says, calculate the length of RC. Leave your answer in third form. Third form is like a radical form, okay? So we need to find the length of RC. RC is this length. Now I want us to notice that we have like a triangle here, a right angle triangle, because yes, we have a right angle triangle here because the tangent is perpendicular to the radius. So we have it according to question 4.1. Now, and then this is given to be 10 units, okay? 10 units, and then that's 20 units. We can apply Pythagoras, okay, to find TC. So we're looking for, to find RC. We're looking for RC. RC here is the hypotenuse of the right angle triangle. So by using Pythagoras, Pythagoras says that R squared equal to X squared plus Y squared. This is Pythagoras theorem. Pythagorean theorem. Okay, so in this situation, we can say RC squared will be equal to TC squared, okay, plus RT squared. So this will be 10 squared plus 20 squared, okay, and then that makes 100 plus 400, excuse me. 20 squared is 400. And then that makes 500. So RC squared, RC then, because we have like RC squared is equal to 500. Now RC will be square root of 500. We can simplify this because RC will be square root of, it's like having square root of 5 times 100, that's 500. And then the square root can be broken down into 2 roots. That will be, if I move it a little bit up there, that will make RC will be equal to root of 5 times root of 100. And the square root of 100 is just 10, so RC will be equal to 10 root of 5. Okay, if you're unsure how to solve this like this, you can just type root of 500 in the calculator. I think most calculator will do that, do the calculations automatically for you. If you it's equal, and then it tells you it's 10 root 5 units actually, because the length. Now, question 4.3. Question 4.3 says calculate the value of K if R lies in the first quadrant. All right, I think I need to move my board over here. this way. Okay, 4.3 now. And then I am just going to place in the diagram here. Now I need to find the value of k. Okay, let's just move this over here. Then what do we have? Okay. So we are looking for k. Okay. And we do know that, and then they said it is in the first quadrant. Obviously, we can see k is also in the first quadrant. Because this is the first quadrant, second, third, fourth. So how can we do that? We know that from the previous question, we did find that RC was equal to 10 root 5, okay? Or even RC squared was equal to 500. So we can use the distance formula, okay? We can use the distance formula to find k. The distance formula is given by this squared, the distance squared will be equal to not square root. It will be equal to x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. That's the distance formula. Then the distance squared is just 500. Okay, will be equal to x2 minus x1. So we can say k minus 3 to the power of 2. Okay, and then plus 21 minus 1. Okay, to the power of 2 also. And that makes 500 equal to k minus 3 to the power of 2 plus 21 minus makes 22. 22 squared is, we can check that in the calculator, 22 squared, and this is equal to 484. So plus 484. Then we can move, okay, this 484 on the left-hand side of the equation. That makes 500 minus 484 equal to k minus 3 all to the power of 2. And then we can do that in the calculator. 500 minus 484, this is equal to positive 16. Okay, I just use what I had there, that's why I have negative, but if you do 500 minus 484, it's going to be positive 16. And then we have like 16 here equal to k minus 3 to the power of 2. Then what I can do is to square root both sides of the equation. I square root here, I square root there, and then this will be plus minus 4, and then that makes k minus 3. Okay, so if I move the 3 over, the 3 over, the negative 3 over, it's gonna be like, let's just first reverse, k minus 3 equal to plus minus 4. I'll move the negative 3 over. That will be k equal to plus minus 4 plus 3. There are two solutions here. Okay, that the first one is k equal to positive 4 minus 3, which means that k equal to 1. Okay, the other one will be k equal to negative 4, because I say plus or minus, plus 3, and then k equal to negative 1. Now, the question has a condition saying that k is on the first quadrant, and obviously we can see that the value of k is on the first quadrant. So the value on the first quadrant, the x are positives, so we cannot take. So this will be not applicable. You see here NA not applicable. Now the solution here, the value of k is just equal to 1. K is equal to 1. Okay. Now what am I saying? Sorry, it was plus here. My apologies. Plus this, k is equal to 7. I mean, k equal to 7. Yes. Because positive 4 plus 3 was 7, and then positive 4, negative 4 plus 3, negative 1. So k equal to 7. The following question says, question 4.4. It says determine the equation of the circle having center C and passing through T. Write your answer in the form x minus a squared plus y minus b squared equal to r squared. Well, let's first move our board over here. So I'm gonna do split the board like that, and then now we do 4.4. So we're looking for the equation, the circle of the form x minus a squared plus y minus b squared all equal to r squared. Okay, so let's first redraw the diagram over here. Okay, here's the diagram. So the circle passes through point C and S. Okay, we know that from the equation of the circle, A and B are just the coordinate of the center. Okay, this is the x coordinate of the center, that's the y coordinate of the center. Okay, that's the y coordinate of the center, and then this is the radius. Now we can write the equation of the circle x minus 3, okay, to the power of 2 plus y minus 1. Okay, we need to be careful here. Usually students may place a positive sign there, but it's because they see positive there. So, but it's not positive 3, but minus 3 here because a is the value of the x coordinates, which is 3, and the negative is negative of the formula, so minus 3, and then y plus 1 because minus 1, okay, to the power of 2 equal to r squared. R is 10 squared, so this can be written as x minus 3 to the power of 2 plus y plus 1 to the power of 2 equals to 100. That's the equation of the circle passing through T. Okay. And then the following question is what? Let's see. Question 4.5. Excuse me. The question says PS, a tangent to the circle at S, is parallel to the x-axis. Determine the equation of PS. All right. Now, I'll move my board here. So I'm gonna write the question here, 4.5. We're looking for the equation of the line PS. All right. Well, so we can notice that PS is an horizontal line, okay? As we can see, and then that horizontal line, horizontal because it is parallel to the x-axis. The white, this arrow, the black arrow tells me that's that the two lines are parallel. So, and then horizontal lines are of the forms. They are the forms y equal to b, or y equal to, or actually y equal to c. Okay, that's the general form of horizontal lines, like y equal to 5, y equal to 10, y equal to 7, and then 5, 7, 10 are all the x-intercepts. So, and then it's going to be the same value all the way through the line. Now, what else? Okay, what else I know from the question? If you look at it, what else we can see here? Yes, we can also see that CS here, okay, is a radius to the question, is the radius of the circle, and it connects at the tangents here. So it's like from C to S is 10 units, because we did find the radius. It is given that the radius is 10 units. So meaning this length here is also 10 units, okay, because the radius is constant. Okay, if it is 10 there, it must also be 10 over here. Now, we can notice that it is from -1, because -1 is here, the y value. The y values are the vertical, okay? From -1 to here is 10 units. So from -1 to 10 means it's equal to 11, okay? -1 to to 0, it's 1 unit. From 0 to 10, 10 units. 1 plus 10 makes 11 units. So therefore, y, the equation y will be, the tensions, y will be equal to -11. That's the tension line, the tension at PS. Okay, the following question is, let's see. Question 4.6. The question says, the equation of PTR is 3y minus 4x equal to 35. Now calculate the coordinates of P, and then calculate giving a reason the length of PT. So I'm gonna move my board over here. Okay. So we have like question 4.6. Let's first redraw the diagram over here. Okay, that's the diagram, and then also you can also paste in the same question. Yeah. The question, let's say calculate the coordinates of P, and okay, let's first start with the coordinate of P. P is this one. Okay. What else? Yes, it was given also the line PTR. So then PR, this line is given by 3x. No, sorry, I wrote it wrong. 3y minus 4x equal to 35. We can double check. (3y minus 4x equal to 45, yes. So now we are asked to calculate the coordinates of P. How can we do that? Okay, we already know that from the previous question over here, that the y coordinates of P is -11, okay? So because it passes through this horizontal line here, so the y coordinate is 11, -11. -11 is there at this point, so P, the y coordinate is also -11. -11, but we don't know the x coordinates. Okay, we can find the x coordinate by substituting the value of y in this equation. Okay, so we can work it out. It's gonna be 3y minus 4x. Excuse me, I meant to say 3y in the bracket like that, minus 4x equal to 35. Now we sub in the value of y, which is -11, and then this will be -33 minus 4x is equal to 35. Now, if I move the -33 over, that makes -4x will be equal to 35 plus 33, and that makes -4x equal to 68. Now we can divide both sides by -4, okay, by -4, then we get x is equal to it's gonna be 15, 17, -17, yes. Therefore, we can check the calculator. 68 divided by -4, yes, negative 17. Therefore, the coordinate of P is -17, -11. Okay, and also calculate giving a reason the length PT. So we need to find the length PT. All right. Okay, if we notice this, we say that this line was perpendicular. Okay, it was perpendicular here, so it's also perpendicular over here. And then we have another right angle triangle over here. So this form another right angle triangle here. Now, I need to find, I cannot really, maybe I can, yeah, I can. Yes. Almost. Okay, we have like this right angle triangle over there. Then we know the length. We know the length here. The length TC is given. So I'm gonna say let's first write here 4.6.2. That was 4. Whatever we did here was 4.6.1. Now we're going to do 4.6.2. We are looking for the length PT. Okay. We have said that we have a triangle here. The triangle is TCP, okay, or TPC, whatever I call it. So it's a right angle triangle. Then what else we know? We know that TC is equal to 10 units, okay. And then PC, we don't know PC, but we can find PC. Okay, before I write that, I say because this is a right angle triangle, let me change. It is a right angle triangle here. Okay, because it is a right angle triangle, we can say PT squared will be equal to TC squared plus PC squared. Okay. The reason is Pythagorean theorem. Then PT squared is what we need, and then we know TC is equal to 10 units, but PC is still unknown. We can find it because we know the coordinate of C, and we also know the coordinate of P. So PC will be the length. Okay, the distance. The distance formula is given by. It's going to be square root of 3 minus negative 17. Okay, all this to the power of 2 plus negative 1 plus negative 1 minus negative 11. Okay, all this to the power of 2. Now all in the square root. So PC will be equal to square root of 3 minus that makes 20. Square root of 20 squared plus 12 squared. And this makes that PC will be equal to 400 plus 144. So PC will be square root of 544. Now we can calculate the length of, no, I think it's wrong here because that makes, no, that not solved by 10. It's 10, so plus 100. And then over here it's 500. So we do 500, yes. Now, previously we did find that square root of 500 is like 10 root 5. Okay, so then we have like PC. Then we can apply Pythagoras, this formula here. So this will be, I'll move a little bit up there. So this will be PT squared. PT squared will be equal to 10 squared plus 500, okay? Because that's PC squared. PT squared will be equal to 10 squared is 100, so 600 equal to 600. And then we can sorry about this. This is not exactly correct because the formula. Okay, hold on. Let me adjust here. My word. we're saying over here is not like, okay, it's rather PC squared, okay? PC squared because PC is the hypotenuse. So it's PC squared, which is equal to yes, TC plus plus PT. Yes, like that. So the values are correct. So we're going to do that makes 500 equal to because that's PC squared, 500 will be equal to TC is 100 plus PT, which is the unknown PT. Yes, if I move 100 over, that makes 500 PT squared, okay? 500 minus 100 equal to PT squared, and then that makes PT squared equal to 400. Now, if we calculate PT, you can see PT will be equal to 20 units. Yeah, by square rooting both sides, PT is equal to 20 units. Good. The next question will be question 4.7. Well, the question here says, excuse me, consider this another circle with equations x open bracket x minus 3 squared plus open bracket y plus 16 close bracket squared to equal to 16 and having center M. Now the question says, write down the coordinates of M. Okay, we can see that the coordinate of M is just these values, okay? 3 and 16 there, we're going to consider them, but careful, the coordinate will be positive 3 and negative 16, okay? Because it was negative 16 and the minus of the formula is given by that. So minus 16, that's why we got positive 16 here, okay? And then 4.7.2, the question says, write down the length of the radius of this circle. Well, when they say equal to 16 here, the length of the radius is equal to 4 because the formula, if you look at the formula over here, given here, it's always r squared. R squared is not the radius, but the radius is r. So 16 is the same as 4 squared. So over here, the radius is just equal to 4. And then the last one says, prove that the circle with center C and the circle with center M do not intersect or touch. All right. Now there is a property that says, let's first move the board over here. I'm gonna move my board on this side. Let's write here 4.7.3. Okay. So to prove that, we know the property says this. Because we want to prove that the circle do not intersect or touch, the property says if the sum of the radius, okay? So if the radius of the first circle plus the radius of the second circle is greater than the distance between the circle, yes. So this is what we need to prove. And now the radius of the first circle is R1 is 4 units. What was that again? You can check here. It was 10 units, sorry. The first unit is 10 units, the radius. And then the radius of the second circle is 4 units. Now, if we do R1 plus R2, okay, R1 plus R2 equal to 10 plus 4, which is equal to 14 units. Okay. Now let's calculate the distance between the center, then the distance between the center. So the distance between the center, the distance is given by, as we know, the distance will be square root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Okay. Now let's see. The first circle, the center of the first circle is given by 3, -1. Okay. So this will be square root of open bracket 3, close bracket square root of 2, and then the y is -1 minus also to the power of 2, and the coordinates of the other circle are of the other center is what? Let's see again. They're given by +3 and -16. Okay, so if we place them over here, +3, so they are sub 3, and then -16, negative makes plus 16, and this will be equal to 3 minus 3 is 0, so this will be 0 squared plus minus 1 plus 15 is plus 16 is 15. 15 squared. Okay, this is just square root of 15 squared, which is 15. 15. Okay, and then okay, if it's greater than over here, if it's greater than, then they intersect. But let's say, let me change the symbol here. So I meant to write the symbol. If the sum of the radius is lesser than the distance between the center, then circles don't intersect. Okay, circles do not intersect. And this is the case because the sum of the two circles is equal to 14. Okay, and then 14 is lesser than 15, the distance between the center. Thank you.